Now today we're going to introduce an important method in solving some inequality problem, that is the method of undetermined coefficient. In another minimization problem, we have certain constraint, in this case a plus b plus c equals 3 variables, and we try to minimize this quantity here. A lot of times this problem can be solved using AMGM inequality or Cauchy-Schwarz inequality, CS inequality. Sometimes it comes down to finding the proper coefficient for the expressions. Now let's do some analysis here. First of all, let's review that AMGM inequality for n variables here, assuming there are positive numbers. Here, this is arithmetic mean and this geometric mean. We're saying that AM, which is arithmetic mean, is greater or equal to the geometric mean. Now for n equal 2, n equal 3, a most commonly used form, and we're going to use that in this problem. Back to our original constraint, we have ABC 3 variables, and we have this expression with 3 fraction terms. In order to use AMGM here, we're going to introduce the term so that when we do the multiplication, this fraction variable will go away. So that's the typical trick. So in other words, if we can find some coefficient x and xa and 1 over a, when we use AMGM for two numbers, and a and 1 over a would cancel, and then you would have this x, which is a constant, to be determined. Okay, this coefficient we're going to use certain algebra to find it later. Now similarly, for a over b, you would have a and b term, and then use 3 number inequality here, right, where you have coefficient y and z, so that when you do the multiplication of 3 numbers, and ab and 1 over ab variable would go away, and y and z are the unknown coefficient. Now similarly, for the 1 over abc term, we're going to introduce a, b, and c with different coefficient here, and when you do the AMGM for the 4 numbers, and multiplication here would cancel abc variable here, and we're going to use this wt as the unknown coefficients. In order for the minimum to be achievable, then we need to make sure that the minimum is going to be achieved at the point of equality. The condition for equality is that all the numbers are equal, right? So in other words, we are searching for this unknown coefficient here on the left-hand side, and this is the quantity we're interested in. Now we have the constraint a plus b plus c equals 3, so we need to make sure that this coefficient have the same coefficient for a plus b. So in other words, t here would equal z plus u would equal x plus y plus w. So in that case, this will become a constant, this is a variable term, and then this is some other constant. So we can use this inequality to determine the minimum value of this expression. Recap. So we have this constraint here, right? And in order for the equality to hold, we have further condition, that is the numbers would equal. In the first case would be this one, in the second case would be 3 variables equal to each other, and here would be 4 variables equal to each other. How do we find out those unknown values? Too many variables, but luckily we have many conditions here, right? So from here we can express everything in terms of a and b, right? We can solve for x, y, and z, and then later we can use this to find out further relation. So from here you solve for x, right? From here you solve for y and z, and from here you solve for t. So we express everything in terms of a and b and c. Now once you have this, and you have further constraint, which is this part equal 1 over abc, and that part equal 1 over abc, we plug in, right? When we plug in, we're going to have 2 additional equations, okay? So and what we did is actually just plugging, the expression here. So what we have is this. From these 2 equations, and you derive the relation between b and a. I express everything in terms of c. Now, of course, another constraint we are given, that is a plus b plus c equals 3. So we have this, we have the constraint, you plug in, that's the constraint for c. The c value here would be the one that would achieve the minimum. Okay, so we're going to use a trick here to split this term here in terms of -1 and +3, and then for the first 3 terms, the coefficient is 1, 1, -1, and here is 3, 3, -3. So we can factor that. Now c is a positive number, so this equation has 2 roots, but then c is positive, so we solve for c. Once we solve for c, we can calculate b here using this expression here, b equal to 1, right? And we solve for a from the second equation here. In the original problem, we had given the constraint, we try to minimize this expression, and we use AMGM so that the trick here is find certain coefficients so that AB and 1 over AB would cancel, leaving only the constant. The values we have found would allow us to achieve equality for 3 cases so that the minimum is achieved. So how do we find the minimum? Just plug in the value here, right? A, B, C here, plug into this expression, and I skip the step again. That's the minimum value. The recap, for this problem, there are many other methods. For example, you can use Lagrange multiplier method, which is very typical for constraint minimization problem. But however, here we use the method of undetermined coefficient and AMGM inequality, very elementary method, but there's a lot of algebra involved. Now for other problems, there may be easier algebra to work with, especially if you only have 2 variables. So this common technique help you understand the steps and be able to use the technique for other inequality problems. And for this and other interesting math or computer science problems, please like, share, and subscribe to the channel.